All right, here's our first video for algebra. The first section we're going to talk about is rational and irrational numbers. This is going to kind of give you an overview of all the different kinds of numbers you're going to be working with in probably the next good couple of years. All right, first let's talk about rational numbers. Rational numbers are numbers that can be written as a fraction or a ratio of two integers. That's the same thing. Let's put a ratio of two integers. Okay, so let's look at some examples of rational numbers. So -6 can be written as -6/1. So that's rational. 3/4. That's the ratio of two integers. Square root of 9. Square root of 9 is 3, which can be written as 3/1. That's rational. How about -2 3/4, which can be -11/4, also rational. Okay? All right, let's move on to irrational numbers. It's a number that cannot be expressed as a fraction or a ratio of two integers. So let's talk about something like the square root of 2. So 2 is not a perfect square. There is no number times itself that is 2, and it doesn't repeat. It's not a repeating decimal once you find the actual square root of 2. So square roots that are not perfect squares, that don't give you a nice whole number answer, they are irrational. And of course, pi doesn't repeat. Now there's a guy that's still looking for the pattern here. So pi doesn't repeat, so pi is also an irrational number. Okay, here are some facts about irrational and rational numbers. So the sum of rational numbers is always rational. When you add two rational numbers together, you get a rational number. The product of rational numbers. When you multiply two rational numbers together, your result is always a rational number. The sum of a rational number and an irrational number is always irrational. Because you're never going to be able to change this into that unless you have some magical superpower. So the sum of a rational and an irrational number is always irrational, and the same with the product. When you multiply an irrational number and an irrational number together, you get an irrational result. Unless the rational number in the product is 0. That's the only time that this isn't going to apply. Okay, so this is the real number system. This is a breakdown of all different kinds of numbers that you're going to come across. So the real number system is broken down into rational and irrational. So right here are all our irrational numbers. Imaginary numbers are irrational too. That's what this E or the I is. Sorry. So the green are irrational. Anything inside of this blue are considered rational numbers. So let's work from the inside out. Let's start with natural numbers. That's the aqua blue. Some people call these counting numbers. So positive numbers 1, 2, 3, 4, continuing on up. Okay, that does not include 0, does not include negative numbers. Next, we're going to take a look at integers. Integers. Oh, sorry. Did I skip one? No, integers include, oh, hold on. There's one that's not in here. Let me go back to this. Let me get my eraser. And in here should be a circle called whole numbers. We skipped one in this. And that includes 0. So 0, 1, 2, 3, 4. That should be included in there. So let's squeeze whole numbers in here. That graphic didn't do it. And we're going to include 0, 1, 2, 3, 4, and up from there. Does not include the negative numbers. Now, integers is what includes all of our negative numbers. So let's go -4, -3, -2, -1, including the 0, and all our positive numbers. Those are integers. Okay? So anything inside the blue is considered a real number or a rational number, and anything inside the green is considered irrational. Rational and irrational numbers are both part of the real number system. Okay, so imaginary numbers are anything that you see with an like this, an I. We're going to talk about those in algebra 2. We won't worry about those. Those exist, and complex numbers exist. So these are things that we're going to talk about this year. All right, one more thing we're going to do before I leave you is we're going to order numbers. So when you order rational and irrational numbers, here's what I do, is I put them all in the same format first. Okay, so I'm going to take 1/3 and I'm going to make that into a decimal. Okay, the square root of 14 is about this, and then 3.5. So now you can put those in order. I put those in order as decimals. I have 33/100, 3.5. This is least to greatest now. Make sure you follow the directions. This is least to greatest. Sometimes the directions will try to trick you. And then you have 741,000. So if we want to rewrite them in their original form, 1/3 would be my smallest, then 3.5, and then the square root of 14. There's my final answer, ordered least to greatest. Okay, so the next one, the square root of 1/4, 1600ths, and -4. We're going to order those from least to greatest. So take a moment and try to put those into decimal format. Okay, so the square root of 1/4 is 1/2 or 5/10, 1600ths, and then -4. So if we're going to write these in original format, we have -1/4, or -4, I'm sorry, is the smallest. And on your worksheet, this is repeating. Then you have -1600ths repeating, and then you go to 1/2. So there's your order for that one. Okay, so let's change. In this last one, there's only one thing to change into a decimal, and that's 1/12, which turns out to be 83 thousandths and the 3 repeats. So let's put these in order, from least or most negative to greatest. And that's all for this section. See you next time.